Today we're doing dimensional analysis stuff. We're going to be taking ratios and we're going to be crossing out numerators and denominators much like what we do with fractions. We also did this last week, one step. Today we're going to get two step. So an aquarium tank holds 117 gallons of water. Here it is. I messed up earlier, so I've already written it out. 117 gallons over 1. How much is this in liters? We're going to change it from gallons to liters. 1 gallon is 3.8 liters. So I'm going to cross out gallons, and I'm left with 117 times 3.8, which gives you 444.6. My numerators label as liters. We don't have any. 1 times 1 in my denominator, so it's 444.6 liters, which makes sense. There should be a lot more than 117 liters. I'm going to give you another example. A boy weighs 77 pounds, so 77 pounds over 1. How much does he weigh in kilograms? So I'm going to change it out of pounds into kilograms. 1 kilogram is 2.2 pounds. Okay, so now you can see I can cross out the pounds, and I'm left with 77 kilograms over 2.2. So 77 divided by 2.2 is 35. 35 kilograms, which makes sense. Okay? Okay, so that was the first problem on your homework, converting between metric and U.S. customary unit systems. Pause this video and do that problem. Okay, let's go to the second problem on that assignment in Alex. This is U.S. customary length conversions involving dimensional analysis. A jogging track has a length of 0.85 miles. How long is this in yards? So I want to change it from miles to yards. First fill in the blank, then using one of these ratios, then figure out our answer. Okay, so I'm looking for the one that has yards in my numerator and miles in my denominator. So this is the one I'm going to fill it in with. In Alex, you can hold your finger on there for a couple seconds, and then you'll be able to drag it over here. And then we're going to multiply numerators. 1760 times 0.85. You can multiply in either order. You get 1,496 yards, which makes sense. That's less than a mile, and 85 hundredths of a mile is less than a mile. Okay? Let's do another one like that. A runner sprinted 138 yards. How many feet is this? Okay, so I'm going to change it into feet. So I'm going to get rid of yards. So I'm looking for the one that has yards in the denominator, this one, or this one. But I want to change it to feet, not miles. 3 feet, 1 yard. So 138 times 3 is 414 feet, which does make sense. Okay, so go into Alex and do problem 2, U.S. customary length conversions involving dimensional analysis. Okay, let's do the third problem now. A cyclist rides his bike 12 miles per hour. So 12 miles per 1 hour. What is this rate in miles per minute? So I want to change it out of hours into minutes. So I'm going to get rid of hours and change it into minutes. So I know that 1 hour is the same as 60 minutes. So now I can get rid of those labels, and I'm left with 12 miles over 60 minutes. So 12 divided by 60 is 1/5, or 0.2 miles per minute. Okay, so that's the first part of the question. Then it says how many miles will he travel in 2 minutes? Well, if it's 0.2 miles per 1 minute, we want to know 2 minutes. So I'm going to do times 2 minutes. And that's going to cross out the minutes, and you're going to get 0.4 miles, which makes sense. He's going to go less than a mile in 2 minutes. Okay, let's do another problem like that. As Venus revolves around the sun, it travels at a speed of approximately 22 miles per second. 22 miles in 1 second. Per always means divide. Convert this speed into kilometers per second. Okay, so I'm going to get rid of seconds and I'm going to change it into kilometers. It says here, assume that 1 mile is 1.6 kilometers. Ooh, I messed that up. I apologize. Weird. 1 mile, we're changing out of miles and changing it into kilometers. 1.6 kilometers. So now I got rid of miles, and I'm left with kilometers over 1. So 22 times 1.6. That gives you 35.2 kilometers. 22 miles per second at this. Okay, 22 times 1.6, 35 kilometers. That does make sense. Yeah, it's got to be more than 22. Okay, so that's part A. Part B, at this speed, how many kilometers will it take to travel 20 seconds? Well, if this is how many per second, we want to know for 20 seconds. So we're going to do times 20 seconds. That's going to be 704 kilometers. It is moving. Okay, next question. Oh, go do that question. It's called converting between compound units basic. It's question 3. Okay, question 4. This is the hardest one. This is probably the last one in your measurement pie. A swim race has a total distance of 22.5 miles. Race officials want to mark the course every 600 yards with a buoy, including one at the finish line. Starting line doesn't need a buoy. It's a starting line. How many buoys are needed? First, fill in the blanks on the left side using 3 of the ratios, 3 of these. Then write your answer on the right side of the equation. So I'm starting in miles, and I want to end in buoys. So the first thing I need to do is get rid of miles. So looking at my denominators, I'm going to go with this one. 5,280 feet per 1 mile. Okay, now I've gotten rid of miles, now I'm in feet. I want to end up in buoys. So I want to get feet in my denominator, either this one or this one. I don't want to go back into miles. It'll give me right back what I started with. I'm going to grab that one. So 1 yard is 3 feet. So now I've gotten rid of feet, and I'm in yards. And I want to end up in buoys, right? So I want buoys in my numerator, and I want yards in my denominator. I spelled buoys wrong. Not an easy word to spell. The one that has yards, not to buoys, yards to buoys. Here we go. Stick that one in. 1 buoy, 600 yards. So now I'm going to multiply numerators. 22.5 times 5,280 times 1 times 1. 5280 times 22 and 5/10 gives you 118,800 buoys. That's way too many. We haven't done our denominators yet. 1 times 1 times 3 times 600 is 1,800. Oops. So I'm going to divide this by 1,800. Gives you 66 buoys. That makes sense. A race with 66 buoys. The race officials can afford 66 buoys, not 118,000. Okay, let's do a similar problem. There's a construction worker building a wall. The wall's 15.5 yards long. It's a long wall. He needs to place a stud every 18 inches. The first stud has already been placed at one end of the wall. How many additional studs are needed if the last stud will be placed at the other end of the wall? First, fill in the blanks on the left side using 3 ratios, then write your answer on the right side. So I'm starting in yards. I want to switch out of yards into feet. So 3 feet is 1 yard. Okay, so now I'm in feet. I don't want to change back to yards. Let's change it into inches. 12 inches is 1 foot. Okay, so now I'm out of feet and I'm in inches. So let's change out of inches and we want to change into studs. 1 stud every 18 inches. Multiply your numerators. 3 times 12 is 36 times 15.5 gives you 558 over 1 times 1 times 1 times 18. So divide that by 18 and that gives us 31 studs, which makes sense. You can get 31 studs. That's the topic, word problem involving U.S. customary length using dimensional analysis. Go ahead and go do that topic. That was your 4-question assignment for the day. You can do that multiple attempts if you're having trouble with it. Go back, rewatch the video. If you finish that, I'd go into Alex and I'd try to finish these 4 topics, okay, if you have time. If not, if these aren't unlocked for you, you need to do some of the easier Alex topics in your measurement pie first. All right, guys, good luck. Talk to you later.